Hello, today we are going to be reading and highlighting Lesson 1 of Unit 3, Water on Earth. If you are highlighting on Cami, feel free to open up your student reader and get ready to mark it up. Otherwise, please turn in your physical student reader to page 4, where Lesson 1 begins. Water's distribution. Message in a bottle. In August 2015, scientists in England received a surprise in the mail. It was a postcard that had spent the last 109 years in a bottle, traveling the world's oceans. This postcard is the oldest message in a bottle that has ever been found. The postcard had a note written on it. It promised a shilling to anyone who returned it to the Marine Biological Association of the UK. A shilling is a former British coin. The postcard in the bottle was sent out because scientists wanted to understand where ocean water moved around the planet. For centuries, people have dropped messages in bottles to study the movements of ocean currents. Ocean currents are the paths of flowing water that push warm and cold water to different parts of the planet. Ocean currents are constantly moving water around the planet. The movement of ocean currents is complex. It is affected by the Earth's rotation on its axis, how much salt the water holds, the temperature of water, land formations on the ocean floor, and wind. Because of this, ocean currents involve interactions of different Earth systems: the hydrosphere, all of the water on Earth, the geosphere, Earth's landforms, including rocks and soil, and the atmosphere, the mixture of gases, dust, water vapor, and other molecules above Earth's crust. The postcard in the bottle was found on a beach in Germany. It was one of 1,000 bottles released in the North Sea between 1904 and 1906. Slightly more than half of the bottles were returned to the scientists. The rest were believed to be lost at sea. It has been so long since the bottles were put into the ocean that the United Kingdom no longer makes shillings. The Marine Biological Association had to find a shilling on eBay after they received the postcard in 2015. Scientists continue to study ocean currents today. However, they now use different technologies. For example, scientists sometimes attach tiny electronic tags on fish that track where they have been. Oceans on Earth. Earth is a water planet. Oceans cover around 71% of Earth's surface. There are 5 oceans on Earth: the Arctic Ocean, the Atlantic Ocean, the Indian Ocean, the Pacific Ocean, and the Southern Ocean. However, water flows between these oceans because they are not actually separated. Instead, they form one massive body of water. That is why scientists have used messages in bottles. The currents carry the bottles on their journey around the planet. Oceans get very deep. The average depth of the ocean is 3,688 meters, or 12,100 feet. In fact, the planet's longest mountain range runs through the middle of the ocean. It is called the Mid-Oceanic Ridge, and it is found at a divergent plate tectonic boundary. This mountain range covers 65,000 kilometers, or 40,389 miles. The average depth to the top of the ridge is 2,500 meters, or 8,202 feet. Where is water found on Earth? Oceans make up almost 97% of all water on Earth. They are filled with salt water. Scientists estimate that if the salt in the ocean could be removed and spread evenly over the ground, it would form a layer more than 166 meters, or 500 feet thick. This is the same height as a 40-story building. The remaining 3% of water on Earth is fresh water. Most of the fresh water is stored in frozen glaciers or ice caps, or underground as groundwater. A small proportion of fresh water is found in rivers, lakes, wetlands, and the atmosphere. Proportion refers to the relationship between things as to size, quantity, or number. Fresh water is important for people. We cannot drink salt water, so most of the water we drink comes from groundwater. Humans and other animals can also get fresh water from lakes and rivers. We're going to take our drawing tool and put a nice little star next to this chart. Make sure that you designate that this chart is important. How water moves. Water doesn't remain in the same place forever. Instead, as the sun heats Earth, energy causes water to move around the planet. As water moves, it causes heat to transfer from the sun through the atmosphere, connecting the hydrosphere and the atmosphere. To understand how this happens, remember that Earth's temperature range allows for water to exist in all three states: solid, liquid, and gas. Water molecules make up the ice found in glaciers and liquid water found in the oceans, rivers, and lakes. Water molecules also make up the water vapor that mixes with air. Whatever state they're in, all water molecules are made up of one oxygen atom and two hydrogen atoms. We're going to take our drawing tool, and over here we're going to write H, put a little number 2 at the bottom of it, and then the letter 0 for H2O. That's our water molecule. And also put a little star next to this diagram. The water cycle. With enough energy from the sun, liquid water on Earth evaporates into the atmosphere. Evaporation is the process of liquid water changing into water vapor, its gas state. As the water vapor moves higher in the atmosphere, it loses heat. Eventually, it will condense. When it condenses, it changes from a gas back into liquid water. Precipitation is water falling back to Earth's surface in the form of rain, snow, sleet, or hail. Some of the water that doesn't immediately evaporate back into the atmosphere will collect into lakes, pools, and other water sources. Some water will seep underground. Water that doesn't absorb or seep into the ground gets absorbed by plants and animals will flow downhill because of gravity. Any area where all of the water that falls into it drains into a common outlet is called a watershed. So you see here we have water evaporating, it will condense, it falls, here it says rain, and then the water will fall into the ground. It will get absorbed by the ground or absorbed by animals or eaten by plants, and some of it will fall into this little river, into the watershed area, and it'll go into the river and the river's outlets and back into the ocean eventually, and continue the cycle all over again. Plants absorb some water through their roots and release it through their leaves as water vapor back to the atmosphere. The process by which water moves through plants from roots to their leaves and into the atmosphere is called transpiration. So that's basically evaporation from a plant. The circulation of water from a collection to the atmosphere and back to the surface is called the water cycle. And we're going to put a nice star next to this diagram. How oceans get salty. The movement of water on the planet connects all of Earth's systems. For example, water vapor is held in the atmosphere. Another gas found in the atmosphere is carbon dioxide. When water falls to Earth's surface, it is slightly acidic because it carries some of this carbon dioxide. This slightly acidic water causes chemical weathering of the rocks on Earth's surface. This interaction is between the geosphere and the hydrosphere. The chemical weathering breaks down the rocks, transforming the matter into new substances with different properties, including salt and other minerals. All water that collects on Earth's surface will eventually flow downhill because of the pull of Earth's gravity. As water flows downhill, it erodes the particles of salt and other weathered matter. All water eventually ends up in the ocean, where it deposits the salt and other matter. Over millions of years, this salt has collected in the oceans, resulting in salt water. And that is the end of lesson 1. Don't forget to finish highlighting and go to the next video.